What's going on, you guys? Mr. Allen here. We're about to graph some logs and inverses. Whew, man, it's going to be dope. All right, we got to graph f of x equals log base 3 of x and its inverse. We're also has to get the equation of that inverse, although we can graph it without actually getting it. We're going to do both. All right, we got some domain, range, and asymptotes to take care of. So let's get after it. First one, we got to graph f of x equals log base 3 of x. There's a couple ways to do this. You can kind of remember some tricks, all right, or what some people like to do is rewrite it in exponential form. So if we loop and swoop this thing, if I had y equals log base 3 of x, I can loop and swoop, whoop, boom, and I've got 3 to the y equals x. All right, this is the exponential form of that log, not its inverse, okay? Although they are going to kind of look similar. So what I can do here is now I can plug in values for y. It's a little easier to plug into an exponential and then get my x values from that. I can go with 0, I can go with 1, and I can go with 2. Those are some easier numbers to work with. So if I plug in 0 here, 3 to the 0 is 1, then 3 to the first is 3, and 3 to the second is 9. We could have also done this by knowing a few things about evaluating logarithms. If I want 1 in here for x, that's because 3 to what power gives me 1, 3 to the 0 power gives me 1. If I plug in 3 here for x, 3 to the first power gives me gives me 3. And then if I plug in 9 for x, 3 to the second power gives me that 9. So the way we think about this is I'm going to use 1 for my argument, I'm going to use my base for the argument, and I can use the base squared for my argument. Those are 3 solid points you can use for graphing any log, but a lot of people find success in this way. So that's what I like to do. Okay, so we've got that one. We can go ahead and plot this. So I've got, and you know what? Because these numbers are going to get a little larger, I'm going to go by 2's on my graph over here. So we got 1, 0. So we're going to go right here. So we got 1, 0, boom. I've got 3, 1, so that's 2, 3, 1. We're going to be right in the middle here. And then I got 9, 2. So 2, 4, 6, 8 and a half. That's 9, 2 goes right about here. Now, for logs, we have a vertical asymptote, okay? And it starts at x equals 0. Because this one did not shift left or right, it stays at x equals 0. So I'm going to have a vertical asymptote like this guy right here. Hopefully we can kind of see that through there. And now I can go ahead and graph this guy. So it's going to follow that asymptote real close. And we're going to kind of curve off to the side. Okay. Now that graph keeps going up as it goes to the right. All right. So that's going to affect things like either maybe domain or range. I'm not sure. Well, let's think here. Domain. How far left can I go here? And this is x equals 0 for that vertical asymptote, right? So I can go, actually I can't even get to 0, right? I got to be bigger than 0. So my domain is going to be x is greater than 0, which can also be written in interval notation. Some choose that 0, positive infinity. So either one of those, they mean the same thing. Both are Gucci. All right, now my range. Okay, so remember I said it was going up as it goes to the right? That is part of the range, right? As we go up and down, that's my range. So what do we have here? Well, it never stops going down. It never stops going up as it goes to the right. So this is going to be all real numbers. So y equals all real numbers, which can also be notated as negative infinity to positive infinity. Lovely. Excellent. And we already said our asymptote is x equals 0. Cool. We can talk about some other things as well. End behavior. Maybe do a little bit of end behavior. Check this out. So as x approaches, what's it approaching here? It's as it approaches 0. Right? So my left side is only going to 0. What is f of x approaching? F of x is approaching, it's going down, negative infinity. And as x approaches, let's see here, to the right, as x approaches positive infinity, what's f of x going to do? F of x is going to be going to, well, it's going up as it goes to the right, so it's going to go to positive infinity. Lovely. Excellent. A little bonus math there. I know I didn't have it written up there, but in my heart, I wanted to do it. You know what I'm saying? All right. Now, let's go ahead and find our inverse. So check this out. I'm going to do a little fun thing here real quick before we find this inverse. We know with inverses, we can switch our x's and our y's, okay? So really, I could just flip-flop this t chart here. I'm going to have 0, 1, 1, 3, and we have 2, 9. But we are asked for our equation of the inverse, so let's go ahead and do that. All right, so the first thing we do here is I rewrite my log equation as y equals log base 3 of x. Then what do we do to find our inverse? We got to switch our x's and y's. So I'm going to have x equals and log base 3 of y. Now I need to rewrite this in exponential form because I got to write this, I got to set it equal to y, right? I got to have y equals something. So how do I get it out of my log? I got to rewrite in exponential form. My loop and swoop is going backwards, right? Because I have the x over here. So we got 3 to the x equals y. And I'm going to have, let's see here, 3 to the x equals y right there. Lovely. And if you're not comfortable with the loop and swoop backwards like that, you can always do this. You can always say, hey, I got log base 3 of y equals x, and now you can 3 to the x equals y. You can loop and swoop the normal direction, right? Either way is cool. I'd get comfortable with that so you don't have to keep on rewriting things. But hey, if you need to, rewrite it. It takes 2 seconds, right? So here is my inverse. This is my inverse of it. So I'm going to go ahead and write that up here. We got 3 to the x. Now, if you look at our t-chart, when I plug in 0, 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9. Even flip-flopping our x's and y's, still got the job done. It's dope. All right, so let's graph this thing. We got 0, comma 1. So 0, comma 1. Remember, we're going by halves, or sorry, by twos here. So we got 0, comma 1 right here. I've got 1, comma 3 right here. And I've got 2, comma 2, 4, 6, 8, 9 right there. Now, for exponentials, I have a horizontal asymptote. So that's going to be a y equals 0 right here for my horizontal asymptote. What if we get that a little bit darker? Let me see if I got a slightly darker blue marker here. Whoop. Hopefully we can see that a little bit better. That one's got a little bit of squeakiness to it, you know? All right. So now I'm going to graph this thing. It gets really infinitely closer to that guy. Whoa, right there. Kind of came off track there. Boom. There we go. It's supposed to be a little bit smoother. Again, you know what? I'm just going to swap over to this blue marker. The other one's fading on me. It's fading fast. Oh, that squeak is terrible. Terribly sorry about the squeak. Okay, that's why I'm not using this one usually. All right, there we go. We've got our exponential. All right, that's excellent. That's wonderful. So how about domain and range? Well, my domain here is going to go everything to the left, everything to the right. All my x values, that's x equals all real numbers, which can also be negative infinity to positive infinity. Excellent, fantastic. Our range is going to be, let's see here. It doesn't ever get to 0, right? So it's always above 0. So we got y is greater than 0, or you can go from 0 to infinity. Perhaps I also label my asymptote here, y equals 0. And we've got that right here in our answer box, y equals 0. Cool. Now, you might be wondering, I'm sure you're wondering right now, end behavior for this bad boy. I'm kind of out of space, but we'll try it. We'll try it maybe right down here. So as x approaches, this time it does go to negative infinity, our f inverse of x is approaching what? It's getting closer to 0, so it approaches 0. Then for the other one, I've got as x approaches positive infinity, what's f inverse of x doing? It's going shooting up, it's going to positive infinity. There we go. Hopefully all that fit. Let me check my fancy watch here. It just made it. It looks like, ooh, barely. All right, cool. That's it. That's awesome. That's a lot of information there. A big thing to remember here, that logs, exponentials, they're inverses of each other. Notice how it would, it would reflect so nicely across this line right here. Ooh, that y equals x line, right? Y equals x. Those two graphs are going to reflect across each other. That's dope. That's awesome. And I will see you dogs on the flippity flop.